Lesson 1, we are in number patterns. The first lesson is actually revision because you need to know what number patterns you already have. Which number patterns do you already know about? Linear, quadratic. That was what you did actually in grade 8 to 10, which was Tn is equal to?
AM plus
C, B, K, whatever you like to say. Some people use other things, alright? Then you knew how to do that. This is going to change. This linear one is going to change this year because it's going to change so that you can do extra stuff with it. Then you also have the quadratic, which was? So we had linear and we had what? Quadratic. Now before we get to new stuff, this is our exercise for today. With linear and quadratic, let's get into the quadratic ones. Exercise. Right. How do we do a sum like this? Our first instinct, if we just write down the sum, is what?
Find
Tn, right? Find those little spider webs, which will then be what are we doing here?
Finding the
First differences. 4,
6, 8.
good. And then we find the
Second difference.
which is 2. And make sure it's not minus 2. How do we do that? Always the second minus the first, the third minus the second, and so we go on. Always. Nice and easy, level 1, and here we go. But listen, read the question. The question said, find the value of the next number in this pattern. I didn't do that because I didn't read my sum. Are you with me? You don't do silly marks because you don't read your sum. First question was, what is this next term? And I haven't answered it. Here I'm going on my merry way and I'm going to do the sum. How would I do that though? You've got to add another 2, meaning this should have been
10.
10. And then this should have been
29.
nice. Will you answer the question like this in an exam?
Yes, no.
Please no. The marker is going to miss that if they're tired of marking. Now it's in there somewhere. Please answer the question. Question number A1 says, the next term is 29, and we highlight and do all sorts of stuff that they cannot miss it. With me.
Yes, ma'am.
It's there, but what if they missed it? Because it's so easy to miss it when it's inside something else. The second question did ask, find the general term. So for the second question, find the general term, we go with what?
The difference, which is 2A.
Ah, yes, 2A,
is equal to
which is your first step. And this one was?
3A plus B.
Excellent. Which is your second step?
A plus B plus C.
That was the pattern that you were taught. Nice, easy marks if you know those things. Right, so we have first step, 2A is equal to 2, so A is equal to 1. Second step, 3A plus B is equal to 4, where A is equal to 1, so B is equal to 1. 4 minus 3. Number 3, A plus B plus C is equal to 1, where A was 1, B was 1, so C is equal to negative 1. Make sure about the silly routine questions that you don't make a silly mistake. Finished? No. What did the question say? Find the general term. I've done everything except write down the answer. Please remember when you are answering a question paper, right? You read the question that says find the general term, you highlight that. You go to your answer and say, oops, I haven't answered that. The general term then will be, now guys, it's good if you write it down. You don't have to write down the general term and then substitute, but you can. So it's 1n squared plus 1n minus 1. And if you want to write the 1 there, all good. This is usually worth about 4 marks. Then the last question, find term number 100. What must I do?
Substitute
Substitute the n with 100. What's the general mistake kids make about the 100? Sometimes they want to put it equal to 100. What would that question have been if it's equal to 100?
Is it quadratic equation?
Which term
Oh.
is equal to
100.
100?
Oh.
That would be this question. This won't work. I'll have something like n is equal to 33 and a half, and then you'll know something's not like that because you read the sum incorrectly. I must make sure that that is actually a term before I can ask you which term it is. Right. So general mistakes is when to substitute n with 100 and when to put the whole term equal to 100. So in this case, I have to say term number 100 equals, and this you don't have to show me, but it's a good method to substitute your n with 100. And an answer, please, with a calculator.
10,099.
And the sum is done, and this sum would have been like about 7 marks. The whole thing. 1 mark, maybe 2 if you're lucky. 4 marks in general. Mostly 2. Because now it depends, if this was wrong, you can still get your full marks here. Whatever your general term was, as long as it's quadratic, can't be linear, then you won't get any follow-up marks. Quadratic, and you substitute it in, you get your full marks, whatever that answer then might be. Right. Alright, so what type of a number pattern is this? Who says quadratic? Why would you say it's quadratic? Because of the square. It's not necessarily the case. The only reason why this is a quadratic number pattern is because the sum said so. Read the sum. It says, if the following is a quadratic number pattern, then find the value of x. They could have just as well said, this is a linear pattern. Find the value of x. They've got to tell you. They can't give you lots of unknowns and then you've got to guess whether it's linear or quadratic. If they actually give you the physical numbers like we just had in the previous one, then you must find out whether it is or not by seeing whether the second difference is the same. But if there's unknown values, I have to say, listen, this is linear or this is quadratic. Now they said it was quadratic. What is the main thing that they're testing? What do you know about quadratic? That's it. There's 2 differences, yes. But the second one is constant. That's where you're going to get a definite mark. But you still need to do what? Find the second difference. First difference, first of all, would be x squared plus 2 minus 6. No problem there. This one would have been 6x plus 2 minus x squared. Excellent, guys. How come is those both 2 a minus? Because it actually should have been in a bracket. This one minus that whole one in a bracket, and then that will be the result. We just always save a little time. So this one will be 11x, the fourth one minus the first one. So it's going to be minus 6x minus 2. So you can imagine where the mistakes are. Always with those ones that should have been timed with a negative. What would you say about us first simplifying before we get to the second difference? Remember, this was the first difference. We need to get to the second. Is there a relationship between the first differences? No. The second difference is where the relationship comes in if it's quadratic. First difference is a relationship when it's linear. So for quadratic, we need to simplify. I would rather want to simplify it first and say this is x squared minus 4. This is minus x squared plus 6x. Do you agree with me? The plus 2 and the minus 2 fall away. This will be 5x minus. Are they equal to each other? No, because it's first difference. We still have to go and look at the second differences, which will be negative x squared plus 6x minus x squared
plus
plus 4. And for these two subtracted, 5x minus 2 plus x squared minus 6x. Are you with me?
Yes, ma'am.
Put it in a bracket if that's going to help you. Okay, but then, very important, I'm going to give you a mark for doing this. Because now I know that you know that second differences stay the same. And now this is a what?
Equation.
Quadratic equation. And the rules are? Get it equal to?
0.
Right, get it equal to?
0.
How many types of equations are there?
Linear, quadratic.
a lot.
Yeah.
Not a lot.
Exponential.
That's it. Linear, quadratic, exponential. This is not exponential. This might turn out to be a linear one if I put all the x squares together and they do eliminate each other, but they're not going to. So there's rules for each of those. For quadratic, we put it equal to 0. Now let's get the sum going, and what's it going to be equal to? Negative x squared, is negative 2x squared, negative 3x squared. Be careful on that. Don't make a silly mistake now. The x's is 6x. Those two add up to negative 1x, becoming a plus 1x, so it's positive 7x. We do it so easily, but you took like years in grade 8 to study this, how to add the stuff. Then we had the numbers 4 and plus 2 giving me plus 6. Then what do?
Trinomial.
This is the trinomial that you've now got to either be able to factorize with your own brain or with your calculator that I'm going to start promoting from day one. I want you to have the new calculator because it's going to help you factorize. Right, so first thing, in any case, you have to divide the whole thing by a negative. Because whether you work with a calculator or not, that's worth a mark. Knowing that you should not have a negative there in the front. Then your calculator, when you take the new calculator, whether it's the silver one or the white one, or every year comes a new edition, you're going to go to, so those of you who have it in front of you, you go to mode, you go to number 5, which says equation. It says there, equation 1, 2, 3. The third one is ax squared plus bx plus c. You're busy with a trinomial, quadratic. So you're going to go for number 3. And then your calculator will say, what's A, what's B, what's C? Is everybody there? So you went mode, equation, and you chose the third one so that it's A, B, C that it's required. For A, B, C, what's required? Can you see what it is? Because this is like a parabola, ax squared plus bx plus c, right? So A is 3, B negative 7, C negative 6. How do we punch it in? Under the A, so it's 3, and we say equals because that's your enter button, like a computer. Then it's negative 7, and we enter, and it's negative 6, and we enter, and then it waits for you to say, do it, equal sign. And the answer then is, there stands x1 equal to, and if you press it again, it will give you the other answer, which is, and you're done. No, I lie. But that's the shortcut way. And now I've got to teach you to manipulate and crook it right so that you get all your marks. Because you were supposed to, whichever way you factorize, go and factorize and find old school, 1 times 3 and 2 times 3, and search for when you're going to get to negative 7. So that one didn't work. So we go 3, 2, 9 and 2. Can that work to get me negative 7? Yes, it can. Negative, positive. So there are my 2 brackets. X minus 3, which will give me 3. But now you've got to work it backwards and say, what should the brackets have been? Going backwards. To have x is equal to 3, this would have been x minus 3. And this, careful now, had to have been 3x plus 2. Excellent. 3x plus 2, old school. Guys, can you still always factorize with your own brain? Yes, but there are other things that this calculator can also do that I want you to have it for. Because how many times do you think a quadratic trinomial factorization is in a question paper? Approximately 20 marks. You want this. You have it. You've got to have it. Okay. Alright. So all the time I'm going to tell you now, punch into the calculator, get me this answer, but you cannot omit or leave out that step. You have to show me that step by working backwards so you're grouping it right. Now, this is the answer. Now, what we should do is actually go and test it now, right? Substitute the x with 3 in everything and see what the pattern looks like. And substitute the x in there, because sometimes one of them doesn't work. These will both work. But, oh, little thing.
Oh,
Let's see.
X is element of all
X
natural
must be a
numbers.
natural number. So,
It cannot be Z.
not because I don't have fractions, because they told me I can't have fractions. It has to be this one. Both of them would have worked if I put them back in there. I would have seen something similar, well, something like the 6 and the 11 and the 18, the previous one. It would have worked. But you needed to be a natural number, so that's why that one is not a ticker. Right, so your homework is exercise 11, page 4, 1B, 2B, 3, 4, and 5. So that we can start off with sequences and series.